Okay, Lars. So I already introduced you as our narasumber, ya. So please
Terima
join
kasih.
and you
Terima
can
kasih, Pak
share.
Ali.
Ya,
Can you hear
okay.
me good?
Please go ahead.
Sound is
Yes,
okay?
I can hear you. Dan nanti akan dipilih dari dua pertanyaan tersebut, dari dua pertanyaan, dari dua peserta, mana yang akan mendapatkan token ya atau voucher. Begitu pula juga nanti akan dipilih dua form feedback dari dua peserta untuk sama juga mendapatkan voucher. Jadi ditunggu partisipasi dari Bapak Ibu sekalian. Oke, Lars. So I already introduced you as our narasumber, ya. So please
Terima
join
kasih.
and you
Terima
can
kasih, Pak
share.
Ali.
Yeah,
Can you hear
okay.
me good?
Please go ahead.
Sound is
Yes,
okay?
I can hear you.
All
Yeah,
right. Good, good. Thank
okay.
you very much. Thank you, everybody. Thank you for PT Tiara for organizing this webinar. So I am going to share my screen now. Let me check if you can see my screen. Please, Adi, can you give me a confirmation?
You should maximize your screen, yeah.
Yep. Okay, let me. So it's not. To do this. Okay, what about now?
Yes,
You can see the
looks,
PowerPoint okay?
yes, PowerPoint, very good.
Okay.
Okay, very good. Thank you for the confirmation.
Yep.
So today I have the honor of talking to you about optimizing the life and performance of industrial lubricants. So this is an area of expertise from my company Fluitec. So I'll start today with giving you a little bit of an introduction, and then we go to some high-level overviews of how turbines fail, what is happening to oils that we see nowadays, and something new in the industry that is called shear stress deposits. We will go into some oil condition monitoring, and then I will talk about some unique and patented solutions that have been approved nowadays by the OEM that you can use to apply to your oil to reduce your cost of oil, but also your reliability will be improved. We will talk about some case studies about these solutions, and then at the end, it's quite a lot of information that we are going to go through today. So I'm going to go through it a little bit fast, but hopefully it will be clear. And please write down any questions you have at the end that we can treat during the Q&A session. All right, thank you very much. So let's get started. Who is Fluitec? We are in the business of boosting our customers' profits, so your profits. And this coincidentally and conveniently also helps to save the planet, because when we use less, your profit increases, but also less CO2 emissions. So that means healthy for the planet. So we have an opportunity to boost profits all the while being more sustainable. So that's a unique situation. And you can see that on the left side here, we have been certified by B Corp and Solar Impulse, which are looking at sustainable solutions in the world. So we can save 50% or more on oil change costs and 100% reduction in chemical waste. So how can we achieve that? That is what we are going to talk about today. So we are going to talk also about something that is called Fill for Life, which is a new methodology that is now utilized and approved by the world's leading energy companies, but also by OEMs such as Siemens Energy and lubricant manufacturers such as ExxonMobil, for example. So we want to go from a consumption model where every time-based interval you change the oil. We want to move to a circular model where we can achieve a lot of benefits, such as longer equipment life, and that's how we can get these 50% savings on oil change cost. So we do that by changing to a circular model where we do a constant cycle of activities on your lubricants, which starts from generating data and then applying the right solutions. That means that we can extend the life of the lubricant to a fill for life lubricant. That means instead of changing it on a time base, we look at the condition of the lubricant. And if we treat it well, if we keep it clean and pure, then we can keep it in the system as long as the system is operating. So in short, that means if you do this correctly, you do not have to change your lubricants anymore. That's why it's called Fill for Life. So that means we change from a consumable to an asset. And this has a lot of benefits, of course. So I always say the biggest competitor to us, or the biggest, let's say, obstacle that we face as a customer, is the way that things are being done right now. It's not some other company that is offering these solutions as well, but we are always fighting the status quo because people are used to doing things in a certain way. And the general consensus is if I'm okay now and I don't do anything, my operations are doing fine, then I'm going to be okay, right? But in reality, we're facing a world with ever increasing costs. In some areas of the globe, it's happening really fast right now. You also have opportunity costs that you will miss because you have an opportunity to be more efficient. The price of flushing chemicals and manpower are also increasing, and good manpower is becoming more scarce as well. And also from governments and industry bodies, there's a lot more scrutiny on sustainability. Everybody is expected to do something to reduce their consumption. So if we don't do anything, we will decrease our profit. It doesn't mean we go bankrupt or there's going to be huge issues immediately, but over time we will be less competitive. So there are major benefits to be achieved by this Fill for Life methodology. And I'm going to show you a case study here now. This is in a gas turbine driven compressor system where this customer, as you can see on the graph, was doing an oil change based on time. So every 4 years, this whole turbine driven compressor system, about 40,000 liters of oil was drained. The system was flushed and cleaned, and then new oil was entered into the system. So at every interval, every 4-year interval, this cost them 350,000 US dollars, right? You can see that here, oil change 350,000, 4 years later, another 350,000. So they trialed the Fill for Life to compare it to their time-based interval oil change. And they figured that they only have to invest 50,000 every 4 years into their system in order to keep the oil running. So they save 600,000 US dollars in oil change cost in this case. And this does not even include the reliability and higher uptime, because normally in these periods where they change the oil every 4 years, they need to do 2 weeks of downtime. They need to get another company, an external company in to flush the system. This costing them a lot of money and a lot of downtime, which during which you cannot produce anything. So you're losing profitability and revenue as well. So this is only on the cost side. They were already able to save 600,000. In reality, their benefits were in the millions of dollars because they had less downtime, higher revenue. So that's how powerful this Fill for Life methodology can be. If applied correctly, you will enjoy these benefits of extended oil life, a lot of cost savings, reduced CO2 footprint, and every reliability engineer's dream, improved equipment quality and reliability. This also increases the quality of your production. So what can we offer in the field to the customer? How do these products look like? It starts with consulting, and what we do today, I think, is also a part of that, where we share knowledge and new things with you. And then condition monitoring are equipments that we sell to laboratory to analyze the oil. And this allows them to be predictive, in some cases even proactive, with their lubricants. And this gives them an opportunity to look at the health of their lubricants and to assess how much life is really left in this lubricant. And that allows them to make data-driven decisions. So for example, Tiara is one of the companies that will be able to provide these ruler and MPC tests for customers to allow to look at the health of the oil. Then we can choose to do contamination control, which are specialized filters, or we go for what is now relatively new, life extension, where we can add solubility enhancers to the oil or certain chemistry that improve the performance of the oil. And when we combine all these things together, that's how we get to the Fill for Life service model. But before we get there, let's talk a little bit about lubricants themselves and how we can optimize them, because what is the science behind all this? That's always very important. We're a science-driven company. So I like to show the slide. Why is it? Because the oil industry is very often perceived as being a dirty industry. It's a dirty brown substance. It's going everywhere, and it needs to go away, and all these things that we see nowadays in the market. But when you look at the reality, there is an opportunity. When we look at how much friction is lost in energy production, right? And that also includes everything that is being produced, that is close to 50%. So you can imagine, of all the energy, all the fossil fuels that are being burned to produce energy, almost 50% is being lost. So the opportunity for optimizing lubrication, that means we're going to reduce this friction. Even if we reduce that by, let's say, 10%, which is technically achievable, you are going to save a lot of CO2. So lubricants, lubrication, tribology, everything that we are doing is actually enormously important in increasing sustainability and in helping to save the environment. So I like to show that because it gives you a bit of a different look at lubrication from being something that's dirty and polluting the environment to something that's actually helping a lot with increasing energy efficient. And it's also for all of us in this industry a responsibility to optimize lubrication so that we can contribute to reducing the environmental problem and to be more efficient, because it has a big impact in the environment. So in order to do that, we need to look at what is an oil supposed to do and how can I help that oil to do its job. So if we zoom in on turbine oils, which are the main oils that are used in energy production, we know that it needs to resist oxidation, right? And it needs to keep the equipment clean. So it needs to provide excellent detergency and deposit control to keep the metal surfaces clean and to keep the lubrication film intact, right? So that's what it needs to do. But unfortunately, in reality, it's subjected to a lot of environmental circumstances and operating conditions that can interfere with this work that it should do. So the three main ways that a lubricant, a turbine oil, is failing in the real world is due to contamination, due to producing too much varnish and deposits, which is then interfering with the oil's ability to lubricate, but also additive depletion. So over time, the additives inside the oil will be consumed by its uses, it will go down, and then the depleted additives will form deposits themselves, and this oil will not be able to resist oxidation anymore if there are no antioxidants left in the oil, right? So contamination will lead to increased wear rates, for example. If you have varnish and deposits in your system, you will experience things like valve sticking and bearing temperature instabilities and things like that. When your additives go down, your oil becomes very susceptible to sudden and rapid degradation, which will then be an immediate reliability problem, allowing you to shut down your system. Luckily, there are solutions to all these failure modes. Contamination can be solved by filtration. Varnish and deposits can be solved by a special kind of filtration called ESP, or we can add something to the oil to prevent the deposit buildup. Additive depletion can now be solved by replenishing additives to your oil. And this is, of course, relatively new and has been recently approved by a couple of big OEMs and is in use by, for example, ExxonMobil is doing this with their oils. So it's a new solution that is going to save a lot of money and trouble. So let's zoom in a little bit on this oil degradation, right? We have a topic, high-level varnish overview. So that's what we're going in now. This picture, fortunately, is not a real picture. It's an AI-generated picture, as you may have noticed. But this is not a real turbine, but it's a varnish monster that is lurking in the shadows, and a lot of operators are facing this issue. So what is varnish? What do we mean when we say varnish? Varnish is actually a chemical change of the oil that is making up deposits. So the oil starts to be consumed and it starts to form chemistry inside. It starts to form different molecules that are then being deposited in your system. So it's coming from the oil itself. And that's why we always say it's an oil-derived deposit. And unfortunately, it's very small molecules and very soft and very malleable, and very often it's soluble in the oil when the oil is going through the filters. So your normal filtration system, your depth media filtration, will not solve the varnish issue. That is the main challenge, right? So keep that in mind as we talk about varnish. So this is what happens on a molecular level. So if there is any chemist that is in this webinar, I have to do the disclaimer that is positioned here on the right as well. This is for illustration purposes only. It's to try to make you understand how this works on a molecular level. It's not an accurate depiction of a hydrocarbon molecule, you know this, but it's designed to make it a little bit more easy to understand what is happening in the process. So imagine this is a hydrocarbon molecule, an oil molecule that you see on the screen. And now suddenly this is subjected to heat and it starts to oxidize. So what happens when a molecule oxidizes, it loses an electron. That means it has a positive charge, right? So it's a charged particle. You can think of something like static electricity, which we all encounter in our life. If you ever, when you were a kid, you would rub a balloon on your vest, for example, and then you could stick it on the wall. It would stick there. You know, that is charging. That is static electricity. By the rubbing, you're actually destroying the molecules and you're creating a charge. So this is also happening very slowly in the oil to your molecules and creating all these little charged molecules, which have a charged head here. So they are attracted to other things because they have a charge. And what they are very attracted to, what they really like, are other molecules that have a similar charge to them. So now you get likes like, that's a chemical term, believe it or not, like dissolves like as well. So they like to go together. They like to bond together and they form. So they're floating in your oil and they make friends as they are floating along and they go together until they have created enough molecular force around their polar heads that they actually start to form a new molecule. So this is happening in your oil. Around this polar head, these molecules are agglomerating and forming now a new molecule, right? Now the oil says, hey, I'm not designed for this. I'm not supposed to have you here. So it doesn't like it. It's a polar molecule in a non-polar fluid. So it starts to be pushed out. And what then this polarity likes to do, it loves metal because metal is also having polarity. So they love to settle out after they multiply and the oil is no longer able to contain them in solution. They love to settle out into the metal. Now, if you know metal, it looks like under a microscope, it has all these crevices and mountains. So these molecules can very easily settle inside these crevices and they will create a very hard layer of lacquer that is almost impossible to wipe. And you will need heavy detergents in chemistry in order to remove this again from your system. So this is how, on a chemical molecular level, varnish starts to appear in your system. And once you have this, it will attract more molecules because remember, these are polar and here is oil flow. The oil is flowing past them. So if you have these varnish constituents in your oil, they love to bond together to these molecules as well. And it will accumulate and increase. So when this happens in your oil, what happens? What do we see in the practical world? First of all, you will see your lube oil reservoir changing in color very often. But the main reliability issue that we see with this is sticking control valves. Blocked orifices to actuator valves, for example, leads to trips during startup. And that's the most common issue that we see when we have this issue. Closely followed by increased wear and higher temperatures on bearings. So the bearing surfaces love to accumulate these varnish, and also it's a condition where the oil is subjected to a lot of mechanical force and pressure. So the molecules are very easy to be brought out of solution and they will form in the bearing layer. So that's the second most prevalent problem. You can also get seal failure because the deposits are increasing the tolerances, allowing gases to penetrate the oil, and that will lead to even more degradation in molecules. But also when we look at heaters and coolers, they are heat exchangers, right? And the oil is flowing. So when they are oil wetted, then at that point where the heating or cooling action is taking place, there is a lot of stress on the oil. And sometimes the oil flow is not that fast. So it gives a lot of opportunity for these varnish molecules to settle out onto the heat exchanger. And then you get an insulating layer of varnish or lacquer on the heat exchanger. And this greatly reduces the efficiency. So when we are able to solve this, we can also prevent all these reliability issues from happening. So let's go through some examples that I've talked about. So when we look at bearings, we can see varnish interfering with the oil wedge, meaning it's no longer able to form an oil film. And then you get these degradation molecules settling out there. And that means the oil will no longer be able to form the film. So you get wear of the bearing. And this will lead to increased bearing instability, vibrations, higher temperatures in general. Also on truss bearings, you can see when they are coated with deposits. And then you get something that is called adhesive or fatigue wear, where there is metal to metal contact. And slowly the particles crack and then they will be released into the oil. And then you get what's called micro pitting. That leads to bigger openings in the metal. You get macro pitting, and this will lead to a failure. And it can be very localized in your system, so maybe you don't even know that it's happening until you really have an issue that is occurring. So this layer that you see here on the screen, this little varnish layer, is like an insulator, so it keeps the temperature. Remember, one of the main functions of an oil is to cool the metal, right? So it's to lubricate, to reduce friction, to prevent wear, but also to dissipate heat, to keep the system clean and to keep it cool. So when there is varnish in your system, the oil is no longer able to do this because this is an insulator that's keeping the heat and the oil cannot dissipate it. So that's what we see when we look at this sawtooth graph here. We see bearing temperature starting to fluctuate. So this is an extreme case where it went really out of hand. But when we see these kind of spikes and then the temperature going down, we are very sure that this is due to deposits because this layer of varnish will continue to change in thickness. So you get a buildup of varnish and then it becomes thinner again. So your temperature goes up and then it goes down again because there's a lot of pressure in the bearing. So intermittently, the varnish gets removed, right? So that's why you get this increase and decrease of deposit layer, which affects this temperature. So when we see this typical graph in your bearing temperatures, we are already 99% sure that this is caused by varnish. So please have a look at your bearing increase, temperature increase. If it looks like this, then we know that we have a varnish issue that we can solve. Valve sticking, here you can see actuators and servo valves. They will stick because it's a very sticky layer of varnish that is in there, and this will block the oil flow or prevent the valve from moving, and that means that the system will not be able to start up smoothly. This is the heat exchanger issue that I talked about. They can have a layer of deposits on them, and that of course greatly impacts the efficiency, which is something that will reduce the efficiency of your plant. Right, so that is general varnish and a high-level overview of what it does to your system. Excuse me. So now let's talk about this new phenomena that we have quite recently discovered that is called shear stress degradation. So what is this that is going on? So just now we have explained to you how varnish can affect the oil as a result of oxidation. So in gas turbines and steam turbines that are used for power gen, we know that the main failure modes are due to oxidation that leads to deposits and varnish. So we know where the reliability problems come from in the oil, but we saw something interesting in other applications, such as petrochemical, where we have a little bit of a different demand of the oil, because these are, sorry, because these are very high rotational speed compressors, very high RPM. So there's a lot of mechanical stress that is being exerted into the oil. And you can see here that some of these compressors have 50,000 RPM speeds or more. So you can imagine that these are gigantic speeds, and the oil is subjected to a lot of stress. So we saw in a lot of cases this bearing instability happening, and it's happening more and more because of more demands on the equipment, higher loads, lower oil sums as well, smaller oil volumes, but also different oil formulations and different properties of the oil. And we see a lot of these cases where we have the bearing temperatures becoming unstable and fluctuating. But then when we do an oil analysis, we see that very often the varnish indicator is still very low. So it doesn't really point to varnish being the issue, but we still see these bearing temperature fluctuations. So what is going on here? We figured that the main mechanism at play is what is called now shear stress deposits. And this is due to the very high temperatures that are generated inside the bearing. So I'll make this a little bit visual for you. But to detect this phenomena, we need to use vibration sensors, temperature probes, or physical component inspections. So it's something that we really have to monitor physically on the equipment in order to detect it. Unfortunately, oil analysis is not always very reliable to detect shear stress deposits. So please keep that in mind in your reliability programs. So we have studied a lot together with the bearing manufacturer. This is a whole mathematical analysis of where varnish tends to form in bearings and how this works. This I'm not going to explain it to you because, to be honest, I also don't understand fully the maths. I needed to have someone with a PhD to explain this to me. So I'm not gonna do that today. But what is important to know is that we have done a lot of research together with the bearing manufacturers in order to figure out this problem, and that is how we discovered how it works. So this just to show you that we have done our homework actually. So what we have found is varnish increases temperatures, and it happens where the oil film is at its minimal thickness. So where the oil is thinnest, the temperature becomes the highest, and then you get in your system, in your big bearing system, you get only a very small patch of deposits that is being formed on a certain area in the bearing, which is usually where the hotspot is, right? So that means the oil itself is fine. It is just generating this localized deposits, and that makes it such a tricky problem to analyze. So we saw that there are some things in the oil, or in the bearing, I should say, that we know only react at temperatures that are higher than 200 degrees C. So for them to be on the bearing, we know, oh, these temperatures must be higher than 200 degrees C. And we're talking about phosphorus-rich deposits here. So we looked deeply into it, and we saw that in the bearing, we have fluid friction occurring. So what does that mean? It means that there is, due to the rotational speed, there is an oil layer that is flowing with the shaft, and there's an oil layer that is flowing with the journal. So you get a layer of fluid that is flowing in one direction, and another layer of fluid that is flowing in the other direction. So on a molecular layer, we get fluid friction, two fluids floating past each other, and this generates heat. So it's very contradictory, I know, but because the oil film is so thin there, and there is pressure on the bearing, this allows to generate heat inside the fluid. So that is causing these temperatures locally to go up to 200 degrees C inside the oil itself. So that means your temperature probes will not pick up 200 degrees C, but they will just see an increase in bearing temperature. But the actual temperature inside the oil can be higher than 200 degrees C. Now the oil is not designed for that, so it starts to decompose and it starts to generate shear stress degradation, and then you get these localized deposits that are attaching themselves to the metal. And then that is what we call shear stress deposits. They will build up over time, and they are comprised of many layers of degradation products. So it can be hydrocarbons that are destroyed there, or additives that are destroyed in that kind of environment that will then attach themselves to the metal. So that's shear stress deposits, right? We will show you how to deal with this and how we can solve it in the end of the presentation. But in order to understand how we can better monitor all of this, we need to start with the basics. So let's talk a little bit about some oil analysis basics, right? So we have a lot of conventional oil analysis at our disposal, but in order to have a very complete turbine oil prediction or condition monitoring program, I should say, we want to perform a slate of tests on the oil, which consists of looking for varnish potential. Now, the main test to do that is called the MPC. The MPC is officially ASTM certified and is now the most widely used test to look for bulk oil varnish. You can also use ultracentrifuge, for example. When we look at fluid degradation, we can monitor how the oil's additives are being depleted. We can do this via the ruler test to actually look at the amount of chemistry that's left in the oil to give us a way of looking at how long this oil is going to last. And RPVOT, a performance test that's looking at the actual oxidative resistance of that oil at any given moment. FTIR is very useful to look at degradation byproducts, which will be oxidation, for example, but can also help you to look at wear metals of the oil or additives, or maybe when you have incompatibility with the oil, that can be that a wrong oil has been dosed in your system, that this will be picked up by the FTIR. Some other important measurements can be done to check that the oil is not contaminated. So this is an example of an MPC test. So with MPC, we run the oil through a patch, then we rinse the patch with a polar solvent to make all these varnish degradation products come out of solution and attach to the patch. Then we measure the patch and we get a number, a delta E number, that gives us an indication of how much varnish potential there is in this oil that we have just run through this patch. So we say anything below 15 is considered normal, anything above 15 to 30 is considered to be a potential issue, something that we can do with. Anything above 30, as now indicated by most OEMs, is critical at this stage. So the number indicates how likely the oil is to form varnish in your system. And I think it's important to show there are some helpful things that we can see physically from the oil, right? The way it flows, whether it has some sediment in there. Sometimes color can be indicative of something, depending on what color. But when we talk about varnish, usually color is not related to the varnish potential. So you see here on the right side a very nice looking oil, light brown, translucent, looks great, but when we run the MPC test, it's actually critical, 37. So this oil is very prone to producing a lot of varnish. Whereas the oil on the left, you think it's dark and it doesn't look very nice, but it's still clean and translucent, so that doesn't mean there's an issue. And when we run it through the MPC, it's actually only 9.1. So actually this oil might change its color because it's doing its job by keeping all of these contaminants in solution inside the oil. So that can also be a good thing. So color is not indicative of how well or not good performing your oil is comes to varnish. We can also look at the colors on the MPC patch as an indication of some issues. So certain additives will give away a certain color. So when we know that it has a typical gray, green, or black color, that's usually indicative of the ZTDP creating issues. So that will then give us a bit of indication, for example. So we have the ruler test and RPVOT. So what can we do with the ruler test? It's a very important test to look at how much additives is left in your oil. So it's always a test that is related to the new oil. So we compare the used oil with a new oil sample. So in this case, we have a mobile DTE 846 that is then compared to the new oil. So the used oil is the red line here. And then we can calculate, oh, there's a reaction taking place. So these are the aminic antioxidants and these are the phenolics. So this oil has two antioxidants, and we can see there is much less reaction here on the ruler test. So that means the phenolics are almost gone because there's no more reaction. But the aminics in this case are still quite healthy, still quite a lot of aminics. So perhaps this is an oil that is still useful. But the ruler will calculate a value that we can then use to determine how much life is left in this oil. How much additives does it have to resist oxidation? So when we trend the ruler test, because it's a trending test, so that's very important, we always look at different samples at different time periods. So this is not one test. This is the same oil tested 6 different times. So this is the first one, second one, third one, fourth one, fifth one, and the sixth one is unfortunately completely collapsed. So nothing to see there anymore. And we can compare this with MPC. So what we see is always a correlation. It's not a direct correlation, but it's a pretty steady correlation between the reduction of additives and the formation of varnish. So the moment your additives deplete, typically your oil starts to produce a lot more varnish on the MPC test. So when we combine these two tests, we get a very good indication of how healthy your oil is and how likely you are to have problems. And this also gives us a lot of data to then come out with an action plan. Because what we want to do with an oil, we want to keep the additive at a very healthy level. That means more than 50% of whatever secondary antioxidant or primary antioxidant is left in the oil. And we want to keep the MPC below 15. As long as we do that, we can say this oil is in a normal condition. As long as an oil is in a normal condition, there is no need to change the oil. So we keep it there. That means you can have your fill for life benefits that we showed in the beginning, and that's how we can generate a lot of reliability benefits and cost saving. So the RPVUT test, just briefly mentioning this, it's also a reliable test that is a very old test, is being done for a long time to look at what is the current oxidation stability of the oil. It doesn't give you any prediction about how your oil is going to be in 2 or 3 months, right? We can only do that with ruler trending. But if you want to know how good is your oil still at resisting oxidation right now, then the RPVUT test can also help to determine that. FTIR spectra can give you an idea of what kind of chemistry is in the oil. It can give you a warning when there are some contaminants, or maybe a wrong oil has been dosed into the system. And it also gives you an idea about how much antioxidant molecules are still inside your oil. The main difference between FTIR and a test like Ruler is that FTIR looks for the molecular signature, but it cannot detect whether this molecular signature is still an active chemistry. So it can also detect dead antioxidants that have already been spent, that have already been used up, but it's still being detected in the ruler test. So that's something that's very important to understand when we look at condition monitoring. Ruler FTIR, sorry, is perfect for looking for contaminants and general chemistry in the oil, but it cannot tell you whether the molecule is working or not working, or still interacting with oxidation. Only the ruler test can do that. So a little bit about online condition monitoring. This is now coming, and this is a new test. So what we see still, even though we do condition monitoring, we sometimes still see a very rapid failure due to oxidation, right? So when you have extreme oil degradation, can be due to contaminant or some circumstance, or in this case it was a coolant ingression, and there were no more antioxidants, and then you have immediately a failure. So to prevent that, we can add online sensors to the oil. So when we look at a general failure pattern of an oil, we see here, these are the ruler values. The green line is the aminic antioxidants. RPVUT is depicted here in the yellow, and the phenolic antioxidants. So it's very easy to see here that when the antioxidants go down, the RPVUT goes down as well, right? So the actual resistance of the oil oxidation when you destroy it in the lab is also going down alongside, of course, the amount of antioxidants that you measure. And then also you see the MPC going up. So this oil starts to produce much more varnish because the additives levels are down. So this is a typical degradation pattern. Antioxidants go down, oil goes up. Varnish goes up, I should say, sorry. So this is the most important criteria to monitor to determine how healthy your oil is. And when you're in this spectrum, you can actually do a lot of action on your oil. So another thing that we can do to give extra certainty is online sensoring. So we can install a sensor that takes a little bit from the oil line at any given interval and starts to run an FTIR spectrum. That's why it's called Fluid Inspect IR. But this is an IR spectrum that is specifically calibrated to your oil. So when we install this, we also calibrate the sensor according to the oil. So it works through the wavelength absorption spectrum of an oil. So it's the same as an FTIR. And this gives you a good spectrum of what is the kind of chemistry that is in the oil. But it's doing this constantly at regular intervals, and it's here installed in your system, and it takes samples so you can have an early warning system. It's optimized to measure the amine or phenol antioxidants that we see in turbine oils. Looks for oil oxidation, because when oil is oxidizing, it's producing certain byproducts that the FTIR can detect. And when we have something that's called solvencer, I will explain that a little bit more, that's a protection against varnish. This sensor can actually also detect the amount of solvencer that is left in the oil, so you will know how good is your varnish protection. So here you can see the oxidation byproducts that it can detect. So this looks for the oxidation of the oil. These are the actual additive levels. So when we added additives to the system, we can see the jump here. So the phenolics and the aminics go up. So this is a good way of determining that your FTIR is actually working, because it was clearly detecting the addition of new additives to the system. So it can also help you to detect how much additives is left. So that's condition monitoring, right? But let's also talk a little bit about some turbine oil performances in the market and selection of turbine oils to help you determine what you can do to select the best oil. So normally the oil is selected based on performance specifications that are shown on a data sheet, but this does not tell you that much about how well an oil is going to perform over a certain period of time. It might confirm that it meets the OEM specification, but it doesn't give you any much more than that. So we have devised a test that is now also undergoing ASTM official scrutiny. So we expect this to become an official ASTM test, where we can predict how an oil is going to degrade. So it's called the turbine oil performance prediction test. An oil is in an oxidative bed, an accelerated temperature, which is an elevated temperature, which is accelerating the oxidation. And then we take a sample cell at 3, 6, 9, and 12 weeks for testing. So every week in this test simulates about 1 year of real world conditions. So 12 weeks, would mean 12 years in the real world. And then we can do some tests on the sample to determine how good is this oil performing. So here we can see a very normal oil. One of the biggest market shares in the world is this oil. And you can see it has quite a rapid increase in MPC, but the additives deplete pretty gradual. So you could actually do a lot of actions on this oil if this would be your degradation pattern in the real world. But what was a little bit surprising and maybe also a bit shocking to the OEMs when we did this with them, when we analyzed 31 different oils that are all approved by the OEMs, we can see that there's an enormous variety in performance. So for you as an end user, if you have a turbine, which is a very valuable asset, you can choose any one of these 31 oils. But of course, if you're going to choose oil number 28 instead of oil number, let's say 6, that's going to make a lot of difference, right? So your neighbor has chosen oil 6 and you have chosen oil 28 and you're having a lot of problems, but your neighbor doesn't have any problems because he chose a different oil. So that's the reality that we are facing in the world. And this is not due to any, let's say, a hidden agenda or anything, any wrongdoing, because oil formulations are always a compromise, right? So a formulation that performs well in one condition might not perform well in the other, but also it has something to do with availability of base oil, market conditions, the willingness of consumers to pay certain prices for the oil also plays a big impact in what they make available for consumers, but also the availability of raw materials and things like that, different branding in different regions. A lot of factors are contributing to this wide variety of performances that we see. So unfortunately, synthetic oils also do not solve the varnish issues. They still produce varnish, as you can see here. So in order to make things easier for the end users, for our customers, we wanted to solve these issues of varnish. So we spent years and I think maybe even decades for product developers to come up with a solution that is easy to use for the customer. And that means we do not have to undergo any downtime due to these issues. And this is now in the market as Decon, a proactive and preventative measurement to varnish. So what does Decon do? It stands for decontamination and deposit control. That means once you have varnish in your system, Decon can help you clean out this varnish and decontaminate your system. So it's a reactive way of doing things, but it can also be used as a proactive way where we are going to add Decon to a system to prevent the varnish from building up in the first place. And that is the deposit control aspect of Decon. So it can be in your system for as long as the oil is in the system. It is classified as a group 5 base stock, so that does not contain any additives. So it means it's very benign to the oil and it's compatible with any group 1 to 5, group 1 to 4 base stock. So that means it's compatible with most oils in the market. Usually it's between 3 to 5% poured directly into the oil reservoir, and fully compatible with group 1 to 4 blended base stock. So that means almost all the oils in the market, definitely all the industrial oils in the market that are used in turbines and compressor oils. And it works safely by slowly removing the deposit, so you don't get a quick dump of material into your system, it really slowly dissolves deposits from your system internals. So it works in a very safe way. So let's go back to our friends here, the oxidized molecules. Let's see how they are doing. This molecule, like we showed in the beginning, is attacked by oxygen and heat. And remember, this is now a charged particle that loves to interact with other charged particles. But this end user has been very smart, and he has bought some decon from us, and the decon is in the system. So now, instead of having the reaction that we saw earlier, we have a different kind of reaction because decon is in the system, and decon is formulated to have an interaction with this exact charge of this molecule. So due to something that's called hydrogen bonding, it is able to form a bond with the charged polar head of this molecule. And that means there is no longer a charge. This is forming a new molecule. And this molecule is no longer interactive, right? So decon has stopped the interactiveness of the molecule. So when we have this in your system, it's a little bit different from before because they are not interacting with each other, right? They're not talking to each other. They're not friends anymore. They don't like each other. So they will just stay floating around, but nothing happens. In the previous slides, we saw the agglomeration of the molecules, but with Solvencer and decon in your system, this is not happening. So there's no agglomeration. That means the oil never has to vacate them. It never has to say, I don't like you, get out of here. You can stay in my fluid. I don't mind. I am perfectly able to absorb you. So they are very benign to the oil and they continue to float around without forming any issues. So this can be in your system for as long as you want. There is no problem occur to this. So that is the proactive way of using decon. But what if we look at the reactive way? What if this varnish has already been a problem and you have formed these layers on your metal? Now we have Solvencer in the system, and through the same molecular forces, it is still attracted to these charged molecules that are already attached to the metal. As long as there is oil flowing past these oils, decon will be attracted on a molecular level to these oils. So it will like dissolves like. So it will be attracted to the polarity of the molecule. And once it goes into the polar heads of the molecule, it has dispersive forces. So the polarity is then reversed, and then you get dispersive forces, for example. So then this dissipates this molecule. It makes this bond, because it's a soft bond, come apart and disperse the molecule into the oil. And when this happens, the oil is reabsorbing the varnish. And this will happen relatively quickly. And then you have a lot of solvencer in your system. So it will convert these molecules into new molecules. And these are completely benign and inert into your system. And it will continue to do this process
Itu
until
jangan
the
weh
varnish
udah
is
usaha
gone.
siap weh dan
So you will completely dissolve the varnish that is present in your system, on your valves, on your heat exchangers, on your bearings, all these locations where the varnish has settled in the metal. Decon will completely remove it. Just to give you an idea, usually when we have a lot of varnish in the system, this equates to about 400 to 500 ppm of material, right? So that is how the actual weight of the varnish, let's say, or the actual volume of the varnish in terms of parts per million. So decon, when we add 3 to 5%, we're adding 30 to 50,000 ppm of solvents or molecules. So just to give you an idea that we really want to overwhelm these varnish molecules with decon molecules in order to be able to combat this issue. So we are having more than enough molecules in the system to combat the varnish. And decon will continue to work for a long time, probably long after you change the oil. And if we have very severe varnish buildup, we can go higher in dosages as well. So decon will continue to work in your system completely safe to use. We've done a lot of compatibility tests on decon, thousands of compatibility tests. So we can guarantee decon is fully compatible with group 1 to 4 industrial oil. It works quite fast. Within 72 hours, usually, if you do an MPC test before and after, within 72 hours, you will see a significant drop in an MPC test. And within 2 weeks to 1 month, you will see differences in the varnish that is in your system. So it will be cleaning up your system. And what is unique about Decon versus other oil detergents is that it's safe to use for a long time. So when we do this TOPP test again, so remember 12 weeks stands for about 12 years of service life. Then when we add Decon after 12 years, there is no significant difference other than, of course, there are no deposits and no varnish. So that's a very good result. But when we look at other cleaning agents, and that are usually detergents, they are not oil compatible. And maybe they are very effective in cleaning the varnish from your system. But if you would leave them in the oil for longer periods of time, they actually start to produce a lot of varnish and deposits. So the Decon is the only currently available long-term solution to varnish compared to competition. So we have also stressed an oil with Decon for 18 weeks, so that means 18 years of real life. The additives were already gone, so no more additives in the oil. But despite that, Decon was still able to prevent the buildup from deposits, as you can see from the catalyst coil and the glassware. The oil color changed a little bit, which is normal, but no deposits or varnish detected. So Decon really gives you a high level of extra safety and insurance against deposits and varnish. So to summarize, what's the most important is that it's a fully oil-soluble cleaner, and it's the only solubility enhancer that can be used in industrial oils that will be beneficial to both short-term for system decontamination and long-term varnish protection. This also works perfectly well in heat transfer oils. It works well in hydraulic oils. So it's not only limited to turbine oils, but we focus on turbine oils because they have the biggest volume of oil, of course. So that is the solution to varnish. But let's look at something else because we want to maintain the health of additive systems in the oil as well. To really have a fill for life oil, we need to look at the additive system. So if we look at the formulation of an oil, typically it's 99% base oil, which can be co-solubilizers, base oil, and then 1% of antioxidants. So industrial oils, specifically turbine oils, usually are like this. But we say when the antioxidant performance, the additive level goes down to 25%, we need to change the whole oil. So that means that in reality, this 1% that we see here is going down to 0.25, and then we change this whole thing. Sounds a little bit wasteful, right? And it actually is, because we have now devised ways to actually replenish only this 1% instead of changing the whole oil, because the rest of the oil is still in a good condition. So why would you want to throw it? We are going to replace just this 1% of antioxidants. Now, in order to do this safely, we need to look at compatibility, right? And for Decon AO, we are going to add chemistry to the oil. So it's a little bit different than Decon. So we want to make sure that there's no issue. So we always do a before and after test or a simulation test. And what you can see here on the left side is before Decon AO. So what is standing out in this oil is high particle count, especially small particle, which are actually agglomerated particles of varnish in this case. This you can see in the higher ISO code. But most importantly, the RPVOT is only 30. That is very, very low. There's almost no oxidation resistance left in this oil. That also shows in the ruler test. So remember, the ruler test is a percentage, a reference test versus new. So when you have only 32% of aminic and 10% or 13% of phenolics left in the oil, this is also very low. So that correlates to the RPVOT values that we are seeing here at 30. MPC, remember the varnish potential test at 33. So anything above 30 is nowadays considered critical by the OEMs. So 33 is actually already in the critical range. So in the past, there was only one thing you can do with this left side oil. You say, okay, we need to plan a shutdown. We need to take out the oil, flush the system with chemicals and do a whole action on it. And then we need to find a new oil supplier or the current oil supplier and buy a batch of new oil. And, you know, we have at least a week of downtime and a lot of capital expenditure and a lot of OPEX related to this action. But now we can say, let's not do this. Let's just add, without any shutdown, 3% of Decon AO into the oil. And then you can see that we have particle counts going down, isocode going down because the agglomerates are being dissolved. And the RPVOT goes up to 960, so that's very close to the new oil. So you've really rejuvenated this oil. You can also see this in the ruler test, 123% and 86%. So more than the new oil, 23% more additives than the new oil had. And MPC goes down from a critical level, 33, to 14.5, below 15 is considered normal. So now we go from an oil that you cannot use anymore, you have to discard, to the same oil with 3% decon AO. It's completely rejuvenated and you're back to almost a new oil level. So you can just reset the clock and you can continue to use this because this oil doesn't create any issues. It is in a perfectly good condition. So that is, of course, a big benefit to the end user. So let me show you some case studies related to this, and then I think we'll be finished just in time. So this is the oldest case study that we have with additive replenishment. In the US, $3.5 million were saved here. In 2012, they started to add decon AO into their system, and they did it again in 2023. So we can see that the life of the oil is here in a percentage, went up to 180%, and now again. So what does this mean for this customer? When we started, their turbine oil was 8 years old, but had to be discarded. Life was extended by 10 years. So instead of discarding it, they use decon AO, and they now have an 18-year-old turbine oil. So we saved the oil and then a little bit of extra. So we think another 10 years is achievable, and then we go into 28 years of life with this turbine oil. And this is a big gas turbine. So you can imagine that this is not normal, and that's why we call it also fill for life, right? Because now we can go for a life cycle of a turbine with one oil. So they had 6 units, 1400 megawatt combined cycle plant, and all of these 6 units had similar results. So we expect to have 30-year-old turbine oils in these 6 large GE Frame 7 gas turbines. So that's what we call a fill for life oil. So this is in the US, but we also have some regional case studies in the power gen sector, for example, in YTL here in Singapore. They did decon AO with Siemens together. So they had a SGT5 4000F, a huge Siemens power gen turbine on a Castrol oil. We did a decon AO compatibility study, and then we went to the treatment. The oil condition was also restored from needing to be discarded to new, and the compatibility report in this case was done by Siemens Energy. We were able to restore the AOs to more than 100% aminic, and again, the oil change and shutdown was prevented. That's where the big benefit to this customer was. So here you can see the example of the compatibility report. Also, we see similar than before here, high ISO code, high MPC 39, actually critical. Then with only 3% of decon AO, ISO code went down, MPC went to 13, and even more importantly, we can see that the ruler values were restored close to new. So that means, let me see, where are they here? The phenolic antioxidant was 95% and aminics at 94%. This was October last year. It's now February. We recently got another report from them, and the oil is still in very good condition. So the customer is using this oil for more than a year now without any issues, and we expect it to last a couple of years more. So we have really removed the need for an oil change, and that is beneficial to them in terms of cost and downtime. So decon AO and ExxonMobil, this is something that we were actually quite proud of, because ExxonMobil is an oil company. So you would expect them to want to sell as much oil as possible, so to not really adopt this fill for life strategy. But they still did, because it saves them so much cost. They say, we rather save this amount of cost because we need to sell so much oil in order to compensate for that. That's never going to happen. So we rather save on the operation side, on the refinery side, because that gives us a lot of benefits. So they really acknowledge the value of this methodology. So these were 2 Siemens Energy compressor trains, higher MPC, also very low antioxidants. So 3% of decon AO was added, and the parameters were back to normal. So this oil was also rejuvenated back to normal, and we expect it to last another 4 years. And ExxonMobil was kind enough to give a presentation in May last year in Kuala Lumpur. at the Asia Turbo Machinery and Pump Symposium, where they presented this life extension of the oil. And this was very, very, let's say, revolutionary, because an oil supplier commenting that their oil could be extended in life and did not have to be changed was, I think, pretty revolutionary. MPC reduced from 20 to 4, antioxidant additives back to new. And this is where you can see the savings again of 350,000 US dollars. And remember, this is a presentation from ExxonMobil. This is not Fluitec that is showing you this. This is our customer. What is very encouraging is that they changed their methodology as well. So they went from a time-based oil change now to a condition-based oil change. And they now accept that antioxidant dosage can help, and changing the way that they look at traditional loop strategy. So that's a big step. We also treated some offshore platforms with this. And also another thing, lastly, that you can use decon for is to prevent a chemical flush. So a chemical flush is very evasive to your system because you're putting a lot of detergent chemistry through your system. Detergents are incompatible with oil. So if you do a detergent flush of your system, then you add a new oil after, and there is some residual detergents, this will immediately cause you a lot of problems. So detergent flush is always a bit risky. It's also not so good for your seal material in the turbine. So we always recommend to reduce the amount of chemical flushing as much as possible. So that can be done with decon as well, because when we do a varnish treatment and a solubility enhancer, well before an overall, we always recommend 4 to 6 months. In practice, that's of course not always possible. You can also achieve good results with 1 to 2 months. So we remove all the varnish by treating it and by adding decon to the system. That means that you can choose without flushing to change the oil system, to change the oil to a new oil. So even if you have no choice but to change the oil, you can still use decon to help you dissolve any varnish and contaminants and deposits in your system. And that means you don't need to use a chemical flush during your oil change, which significantly reduces your downtime. And it also reduces the cost of the oil change, because flushing chemicals and manpower involved with that is simply very expensive. So we always want to look at the risk factor. We look at oil analysis. We decide whether to flush or not to flush. And what is very helpful, I recommend everybody to have a good look at this, is that there are new standards for flushing. Recently, last year, the ASTM D6439 has been amended and is now updated to include solubility enhancer as a viable way of flushing your system. So please, if you do flushes, have a look at this and make sure that you're following the latest ASTM guidelines, because you can really gain a lot of profit by changing from chemical flushing to solubility enhancement flushes. So this is an example of what we did in this way in MSD, a pharmaceutical manufacturer here in Singapore, very high-end company, very complex manufacturing. In its solar turbines, they changed the oil from Shell to Mobil DTE, and they used decon as a flush, so they did not do any chemical flush. Their oil was in a really bad condition. You can see here 30 TEN, so very high acidity. This oil was completely oxidized. They first added 5% of decon before the oil change. Then after, they also added 3% to prevent this issue from happening again. And now they are having a very stable oil condition as well. So here you can see some pictures. This was their system before the oil change. So you can see how bad it was. And we were able to clean this completely. You can see here the acid number from 29. And then we changed the oil. And after the oil change, everything was running very normal. The additives were healthy. MPC very low. So very good results. We also see a lot of decon that is being used to control these bearing temperature trends that we showed you in the beginning. So when we clean the bearing with varnish, the temperature will stabilize. And you can see that here very clearly in this bearing temperature trend. So another, in closing, I will talk only a few minutes about ESP. If you prefer to remove varnish via filtration, then we can use electrophysical separation or ESP to remove varnish from your system. So it works differently from depth media filters. And what is beneficial of ESP is that it really takes out the antioxidant consumer. So it also helps to extend the life of your oil by at least 50% because it removes all of these reactionary byproducts that is coming from the oil degradation, and it helps the oil to last longer. It helps the additives to be more healthy. So we cannot prevent any free radicals from being formed, but we can prevent the reaction from going out of hand. So we can remove the antioxidants consumers. That means you will have a 50% increase in oil life. As you can see here, 55% improvement in oxidation stability. And this is how that works. So we can add resin media into the oil flow via kidney loop filtration system. It's a very low oil flow because the oil needs to be saturated or the resins need to be saturated with the oil for a while for this interaction to take place. And then this varnish constituents get really absorbed into the resin media. So in the right picture here, you can see all the 3 stages of that. There's a virgin resin bead that's visible here. And this one here is in the process of absorbing the varnish, and the one that's floating here on the top, these two that you can also see increased in size, they are actually already saturated, so they are absorbing the varnish. So typically with resin media, every 6 months you want to change it because it will get saturated over time, but it's also a very effective way of reducing the MPC and keeping your oil in a clean and pure condition, and that means you will enjoy more longevity and less downtime. This is what we have done, for example, in Senoko Energy in Singapore, one of the largest power gen companies in the region, with a 2,800 megawatt turbine. There was a Siemens Energy turbine and a Mitsubishi Heavy Industries turbines, also with Japanese OEMs. We have a good relationship. You can see that the MPC here is very stable, remaining low since 2019. So from 30 to 19. Okay. So now we have reached the end of my presentation. I hope it was clear. I saw a lot of chats appearing, so I don't know how many questions there are. I didn't look yet, but feel free to let me know any questions, and thank you for the opportunity to present to you today.
Thank you very much, Lars, for your sharing, and it's very insightful presentation, yeah, because shear
Thank you.
stress deposit is I think is a new challenge, yeah, in the industry.
Mm-hmm.
And then along the way, yeah, a lot of question in the chat box. I
Okay,
think
good.
uh double digit.
Double digit.
but but meanwhile we have a limited time, so I think I will choose, yeah, around
Yeah.
3 or 5, yeah, in
What
this
what I
session.
what I recommend, Adi, what we can do is we can note down all the questions if someone can make a note of it, and then I will look at it and reply them. You can send it to the participants later on if you have the contact details.
Yeah, sure thing.
Right.
And quite interesting in the chat box is some one customer share their trust bearing. So
Mm-hmm.
I will inform you, yeah, in the next question. So first question, yeah, from Mrs. Ahyani, yeah, from Pearl Pulp and Paper. So regarding the shear stress,
Mm-hmm.
what kind of physical component should we inspect, yeah, to confirm or to check the shear stress failure mode?
Yeah.
And Sam uh, attendee that questioning about another question, yeah, how to identify the particle that trap on the filter or membrane filter is actually varnish or gas deposit. So maybe you can answer.
Yes, great question.
Yeah.
So the first one on the shear stress deposits, there's a couple of things that we can do. I think the main thing is to monitor temperatures and vibration, because once you have shear stress deposits in the bearing, you will see these temperature fluctuations that are showing a sawtooth pattern. So that is the main indicator, an early warning system, as you would say. Sometimes you also see some vibrations because there is some added pressure onto the shaft because of the varnish layer that is going against the oil flow. So that will cause some vibration. So these two methods are usually the least invasive. If you do physical component inspections, that typically happens already after you know there was some issue in your system. But then you will look at either the truss bearing pads or the journal bearing sleeve. So really the contact point where the oil is flowing at its thinnest level between the shaft and the journal bearing pad. So that is usually where you see this shear stress issue occurring. And the second one, if you have deposits trapped in your depth media filter, typically these are not varnish material, because what is defined as varnish is organic oil-soluble molecules. So even when they show up in the particle count, because they have agglomerated, they are still very soft and very soluble. So when they are actually in the oil, especially when the oil is warm, when it's above 60 degrees, they tend to dissolve, and then they will simply pass through your filter membrane without being disturbed. So if there is something that is clogging the filter membrane, typically that is not considered varnish. It can happen that you have a very fine filter that's actually taking out some varnish. It can also be that you have an oil cooler where the oil is cooling down that allows the varnish to precipitate into the filter. So in that case, we can do a bit of visual analysis. I would also run an MPC test to the oil, because that will give you a very good idea whether there's varnish in the oil. So Tiara can help you to perform an MPC test. If you want to really go that far, we can also do even a deposit classification, where we either do an FTIR or we do a special test to really determine what is exactly in these deposits. So there's various things that we can help you with to determine what is clogging your filter.
Okay, okay then. Thank you very
Oil
much,
has a high
Lars. And
MPC and it's cold at the point of flow in the filter, then it's likely to be varnished. So that's where I would start looking.
okay, I agree. Okay, we go to next question.
Mhm.
Uh, Let me share some picture from one of customer. Yeah, could
Mhm.
you see it, Lars?
No, not yet.
But need to enlarge. Yeah, right at the moment, can you see it? It's a picture of truss bearing that have like gold color, yeah, and black color on the truss bearing. So the question is regarding how to confirm, yeah, the bearing have a varnish or it's because of stress, yeah, shear stress.
I cannot see the bearing, Adi, I'm sorry. You
Okay.
can you put it in the chat maybe?
Yes, already.
Already in the chat? Okay. Sorry, I cannot see it.
So, but
Yeah, this
right
one.
now, can you see it?
Yes, yes. So this is very interesting. I don't know if you can zoom in a little bit. Yeah.
Yeah.
So this is a little bit of a combination of both that I see, but it's definitely also shear stress deposits. What is very a telltale sign of shear stress deposit is when you have an uneven distribution on the bearing pad. So when you have bulk oil varnish due to oxidation, we typically see an even layer over the whole bearing pad. But with shear stress deposit, you really see it accumulating at one very specific point where the hotspot is occurring and where the oil is at its thinnest. And that's exactly what you see here in this bearing layer. So you see on let's say the top two on the left hand truss bearing, the top two pads, right? They are the clearest visible. You see on the left side, you see this brown spot
Yeah.
that
Yeah.
is much darker than the rest of the bearing, right? So this is
So,
exactly where the hotspot is generating the shear stress deposits, and that is where they are accumulating. So this is a very nice example of shear stress deposits.
okay. So to confirm, is it shear stress or varnish, we can do the MPC test, or we
So
can
that
combine it, yeah, with
well,
vibration or
to be
okay.
honest, this is the best conclusion that you can get because you have a physical and visual confirmation, right? That we can 100% confirm that this is shear stress deposits. Uh,
Okay.
if it is
Okay.
only shear stress deposit, so it might be that the bulk oil also has some varnish that you will pick up with MPC. But if it's only shear stress deposits, then unfortunately the MPC test will not pick it up. So there is at this moment no oil test available that can reliably detect shear stress deposits. So the visual component inspection, like we are doing here, is the most reliable way of determining that.
So, related with this picture, yeah, it's I think it's a gas turbine bearing,
Mhm.
and one of question from attendee that is there any connection, yeah, between the material used to make a turbine equipment and the rate of varnish deposit in the turbine? So is there any effect of material use for in the turbine?
That's a very good question. The material used to make turbine equipment and the rate of varnish. Yes, so there is a correlation because let's say some materials of a turbine are designed to have a little bit of penetrability. So that means they are allowing a little bit of wear, so that the wear particle will be ingrained in the metal instead of causing an issue. But that will also increase the likelihood of varnish buildup because then you have a little bit of porousness in the metal that will then allow molecules to stick onto the metal. So that can have an effect. Also that's a bit different. That's not really related to varnish, but for example, in the bearing, you have a babbitt layer, which is
Mm,
designed to reduce the friction and also to allow for wear materials to be ingrained into the babbitt. But when this material is compromised, it's also very prone to further degradation, and it cannot really withstand very high heat. So then the metal will deteriorate and will even melt, and then of course that will create a spot where you get faster varnish increase. So there is some correlation indeed. There are no direct solutions in terms of material. Well, you have non-lubricated bearings, ceramic bearings, but they are still
mm,
extremely expensive. So we don't expect to see them being used widely at this moment. Even in aircraft engines, you don't see them that much. So
yeah.
yeah, there is some correlation, but I wouldn't say it's very significant at the moment. But there are some reasons for the varnish forming in a certain way due to the materials used. Yeah.
Okay. Okay then.
Mhm.
Uh, Still have a moment for one question again, Tim. Okay. Another question. One last question. So after we have a issue with varnish and confirm with MPC test, so the solution will be uh, maybe varnish removal unit and oil solubility enhancer. Yeah.
Mhm.
So maybe one question is regarding the varnish removal unit. They're using uh, zero point 0.5 micron cellulose filter. Yeah.
Yeah.
So maybe you can share your experience about this kind of removal unit, varnish removal unit.
Yeah.
Yeah,
Okay.
okay.
So if it's a depth media filtration of 0.5 micron cellulose filter, right? So
Yep.
that, I mean, it's a bit tricky to say because without having a lot of knowledge about the exact application and oil type, I'm sure that if it's tailored to your application,
Mm,
then it can work just fine. But you need to have a low temperature of oil when it goes through the depth media filter, because if not, the particle will be solubilized in the oil, and then not even 0.5 micron will be able to filter out the particle. Now,
mm,
that's one thing. Um, you need to make sure that it's tailored to your oil and that it's actually in a circumstance where the varnish is in suspension when it passes through the filter, not in solution.
okay,
Only then it
okay.
will be filtered out, right? So those are important factors. But what's also very important when I hear 0.5 micron, you need to take into account that additives like ZDDP, which is used as an anti-wear agent in some oils, not turbine oils usually. So if it's a turbine oil, then it will not be in there. But in certain other oils, even engine oils and things, there's a lot of ZDDP. It's probably the most widely used additive in the world. And that has a micron range of, I think, 0.8 to 1.5. So a zero point 0.5 micron filter will take out the ZDDP additives. So if you
Okay.
use it in let's say in hydraulic oil, then that might create a lot of issues. Also, anti-foam molecules can also be of the similar size, so they can also be stripped from the oil at this level of fine filtration. So that's definitely something you want to take into account. So a lot of things can work, but you really need to take into account all these factors to make sure that it's working for your application.
Okay. Okay. Thank you, Lars, for your answer. So
Most welcome.
due to limited time, so I think on the chat box there are still a lot of questions need to be answered, and we can answer it separately through email.
Yeah, I want to see also the one question I would like to answer is, which I saw passing by is very interesting. If the Decon AO and other products are compatible to all turbines and compressor manufacturers, or just the two manufacturing only? A very good question. So we have run these products in every single turbine and compressor that's available, from Chinese OEMs all the way to Siemens Energy in Germany. They are operating all around the world, very remote areas in Arctic conditions, all the way to Indonesia in the tropics, or in desert conditions in the Middle East. So in offshore conditions with salinity and a lot of seawater ingress. So in any conceivable circumstance with any turbine that's currently being produced or compressor, these products are working really well. Same goes for the oil. So any oil that is used that's using a normal formulation and base stock, these are compatible with it. So, and we can always run a compatibility test, and we can get the OEM involved if necessary. Why are we showing always let's say the Siemens Energy and Solar Turbines? And we've also done a lot with Atlas Copco, for example. Mitsubishi Heavy Industries, we've done a lot together with them. So it depends really. Some OEMs are very willing to give a lot of advice to the customer, but some OEMs are simply also taking their hands off of it. They don't really want to give any advice about third parties. So in that case, it becomes a bit difficult to get the OEM involved. But what we can keep in mind is a product like Decon is not changing your OEM approval on the oil, because it's not giving any significant change to the oil formulation. You're not adding any additives. So if you are using an oil that has a lot of OEM approvals, when you use Decon, this will not change. Your OEM approvals will still be valid. So I think that's very important.
Okay, Lars.
Thank you.
So thank you very much for your very insightful and fruitful
Most welcome.
knowledge. And uh, I will use bahasa. to close this webinar, and after that we will, I don't know how to say, choose participant we already have a question, and they will we will share memento, or we will share like a token for them.
Nice.
So
Thank you very much, everybody. Appreciate it.
ya, so baik Bapak Ibu, untuk sharing terkait dengan